Hello, this is the water filtration challenge for Module 2. We were posed with the question, can you clean the water? And this is an inquiry-based lesson. We were provided with only the materials and we had to come up with a water filtration system on our own. So I had to decide where to start. All I had to say was science experiment and my 5-year-old was hooked, as you can see. After thinking about the problem of filtering dirty water and looking over the materials that I was provided, I decided to come up with a plan using water bottles instead of the cups that I had originally looked at. I found myself asking questions: which materials would filter best, which should be the first step, which should be the last, and why. So then I decided to design my prototype, and I started by cutting the water bottle in half and then placing a layer of cheesecloth in the bottleneck of the bottle. I put the lid back on and poked some holes in the lid of the bottle. And you can see my little helper, he added a layer of sand on top of the cheesecloth. The process was kind of repetitive. It included poking holes in the bottom of each bottle, adding cheesecloth as the bottom layer, and sediment on top of each cheesecloth. I used a coffee filter in between each bottle. And going back to that slide, the rationale for layering the gravel, then the charcoal, then the sand, I was thinking that the gravel would filter out any large pieces of sediment, the charcoal could refine the water further, and then the final step, the sand could clear out the rest of the sediment. As you can see, I have my final filtration system, and you can see how muddy the water actually was that we used. This was probably my son's favorite part. We went out to the creek out back and at the back of our house and got a bucket of water, added some extra dirt and started around with a stick, and then it was time to put our filtration system to the test. So the water began to filter through, and it was coming out much clearer than it went in, but it was at the point where I still wouldn't drink it. So you can see that I did the part that we saw in the video with the men filtering water by the stream. I added alum to the water, to a separate glass of water, and then added the alum water to my filtered water and let it sit for about an hour. So you can see my filtered water here on the left, and my tap water on the right. So just as a comparison, the filtered water is still a bit cloudy. This was before the alum had some time to settle. We use the alum because it neutralizes the electrical double layer surrounding the fine suspended particles in the water, allowing them to stick together, and then the particles that are in the water end up being large enough that they can settle to the bottom and they can be removed. So in this picture here, I have my water that I ran again through the filter with the alum. I have my tap water, and then I have some leftover sediment after the alum was added, and this was the sediment that settled to the bottom. And you can see that my filtered water and the tap water look pretty much as, the same. After completing the experiment, I couldn't help but think of what I could do to make this more efficient or better. I came up with some questions that are reflections and modifications that I could have made. It took quite a long time for the water to filter, so is there a more time efficient way to doing this? Could I use different materials? Could I use bigger bottles, constructed in a different way? Another problem that I had was that water was absorbed into the coffee filters that were layered in between bottles, and then it was dripping out onto the counter. So if I was in a dire situation and I needed to conserve water, is there a process to make this less wasteful? Obviously, making sure that the coffee filter wasn't hanging over the sides and making sure that the water was going back into the bottles would probably be the best idea. Finally, I had a final coffee filter before the water went into the last cup, and that got saturated with water and tore, so I ended up having to hold my bottle. So I needed to think of a better way to suspend the bottle so it was self-standing. When looking at the inquiry continuum for this activity, it was mostly learner self-guided. We were provided with the question, can you filter the water, and materials, but we were given no direction. So I rated section 1 kind of lower on the scale because we were provided with what we were supposed to do. Every other area, 2 through 5, I gave it the highest score for learner self-directed because we were asked to determine what constitutes evidence, collect our own evidence, formulate explanations, summarize the evidence, look for other resources, and then communicate our findings through our presentation. In conclusion, this inquiry lesson was not only fun and engaging, but it required higher order thinking, problem solving, and hands-on construction of a working model. A student completing this activity would be required to answer the scientific question, can you filter water, by designing a plan, analyzing evidence, constructing an explanation, and communicating their findings. In the last few days of school, I'm hoping that I can get some time to do this activity with my 6th grade students and see how they approach this lesson. Finally, I did some additional research and I found a water filtration project that's close to home. This article talks about Penn State engineering students who designed a portable ceramic water filtration system for communities in need. So here's the link, and I will also post it to the board with my project. Hopefully everyone had as much fun doing this project as I did. Thanks!